So remember 4.1, section 4.1 was about learning how to solve by graphing. Now 4.2 is we're gonna learn how to solve by substitution. Substitution, what it means is to replace something with something else. When you replace something, is what we call substitution. And that's exactly what we're gonna do. We have two equations. One of our equations we must have a letter by itself, whether it is x or y. Here I have y by itself, so 2x, which is what y means. I'm gonna write the first equation, but instead of y, I'm gonna write 2x. And once again, y is 2x, so I'm gonna replace it with the y on the other equation. So let me rephrase this. We get from the two equations, one of them we get a letter by itself, in this case y, and whatever that means, we're gonna replace it for that y on the other equation. So I'm gonna rewrite my first equation, 3x plus 5y equals 26, but instead of y, I'm gonna write 2x. So I have 3x plus 5 times 2x equals 26. Notice how I wrote 3x plus 5y equals 26, but instead of y, I wrote 2x, right? We replaced it. That's why we call it substitution. So our goal technically is to write an equation with only one letter, right? X, in this case, x. All right, let me get rid of parentheses. So I have that 3x plus 10x equals 26. I can simplify the left, right? 3x plus 10x, that gives me 13x. So 13x plus 26. Let me divide both sides by 13. And I get that x is equal to 2. That gives me half of my solution, right? Because I need an x value and I need a y value. Now, to find y, I'm going to use the equation where y was by itself, y equals 2x. So I'm going to write y equals 2, but instead of x, right, instead of writing 2x, instead of x, I'm going to use the value 2. And the reason why, because I know that's what x equals. So I'm going to replace x with a number. So I'm going to get that y is equal to 4, right? 2 times 2 gives me 4. So now my solution is the point 2, 4. So remember 4.1, we learn how to graph. We will graph my lines and then write what they will intersect. That was the solution. Now here, we're going to solve it algebraically. My solution is 2, 4. Okay, let's take a look at another example. Remember, one of the letters must be by itself. In this case, my second equation, x is by itself. So everything that x is equal to, I'm going to replace it for the x on the other equation. So I'm going to write 2, but instead of x, I'm going to write -1 minus y, and then plus 5y equals 7. Notice I have 2x plus 5y equals 7. It's just that I replace my x with -1 minus y. All right, get rid of parentheses, distribute the 2 to the inside, so we get that -2 minus 2y plus 5y is equal to 7. We can simplify the y's. So I have that -2, because that has nothing to do with the y's, plus 3y is equal to 7. Now my -2, let me move it as a +2. So I get that 3y is equal to 9. Divide both sides by 3. So we get that y must be equal to 3. That gives me half of my solution. Now for the other half, once again, I'm going to use the equation where x was by itself. So I have x equals -1 minus y. So -1 minus, but instead of y, I'm going to write 3. Once again, I know that's what y equals. So x must be equal to -4, right? -1 minus 3, that's -4. So my solution is going to be the point -4, 3. Notice that even though I solve for y first, my first number is not y. Remember, on my solution, I had to put them in order, x value, y value. It doesn't matter how do you solve them or which one you solve first. The x value comes on the left and the y value comes on the right. So my point is -4, 3. So this is becoming simple. Take a look at another case, solve the system by substitution. But now here our problem is that we don't have an equation with a letter by itself. So looking at my first equation, let me write x plus 4y is equal to -1. I can easily get the x by itself if I move the 4y to the other side. So I'm going to have that x is equal to -4y minus 1. So once again, the first equation, this one, I don't have it. This is what I have. Right? I got the x by itself. So okay, so now that I have that, everything that x is equal to, I'm going to replace it for the x on the other equation. So I'm going to use 2x minus 5y equals 11, but I'm going to write this as 2 times -4y minus 1 minus 5y is equal to 11. So once again, I wrote 2x minus 5y equals 11, which is my second equation. But instead of x, I wrote everything that x was equal to. Now, let's get rid of parentheses by distributing the 2. So I have that -8y minus 2 minus 5y is equal to 11. We can combine the y's, right? -8, -5, that gives me -13. So I have that -13y minus 2 is equal to 11. Now my -2, let me move it to the other side as a plus 2. So I have that -13y is equal to 13, right? If we divide both sides by -13, I think you guys can agree that y is equal to -1. Right, so we have the value of y. Now let's get the value of x. And the way I'm going to get the value of x, the equation, I'm going to highlight it over here, where x was by itself. I'm going to rewrite it again. But I'm going to go x is equal to, it's -4y, so I'm going to have -4 times -1. Because once again, that's what y equals to. So -4y minus 1. So I have that x is equal to 4 minus 1. Right, -4 times -1, that's what gave me the 4. I did my multiplication. And 4 minus 1, I'm going to call that 3. So my solution is 3, -1. Right? Simple. Now let's take a look at this one. I want to have one of the equations, I want to have a letter by itself. So let me take a look at the first one. Let me write it here at the right. 3x minus y equals 4. I can easily get the y by itself. So let me subtract the 3x. So I have that -y is equal to -3x plus 4. Divide everything by -1. Because once again, we want the y by itself. So we have that y is equal to 3x minus 4. Okay. So now that once again, this equation, I don't have it. I made it into y equals 3x minus 4. Now, everything that I have for y, right, everything that I have for y, I'm going to replace it for the other y. Now here, I have -9x plus 3 times 3x minus 4 is equal to -12. Okay, let me get rid of parentheses by distributing the 3 to the inside. So I have -9x plus 9x minus 12 is equal to -12. We can combine the x's, right? -9x plus 9x, that's 0x. So that basically they cancel each other off. So I have that -12 is equal to -12. Notice how I cancel my x's, or I cancel my letters. Whenever you cancel your letters, that is one of our special cases. Remember back in section 4.1 when we were learning how to graph, some of them had no solution or infinite many solutions. Remember no solutions when they were parallel, infinite many solutions when they gave you the same line. Those were our special cases. Now in substitution, our special cases are gonna come out like this. We get rid of all the letters, we just have numbers. If I get the same number on both sides, like our case, negative 12 equals negative 12, if I get the same number of both sides, that's going to be infinite many solutions. All right, if I was to graph this two equations, they will give you the exact same line. So that's our case when we get the same number on both sides, infinite many solutions. Now the case we're gonna see no solution will be something like, let's say I had like negative 9x plus 9x plus 3 is equal to 4. Let's say we had that, where our numbers are gonna cancel out, and I will get something like 3 equals 4. When our numbers are different, that's when we call this no solution. So once again, our special cases, when I call it special cases, when they have infinite many solutions or no solutions, they're going to come out in substitution. We're going to get rid of all the letters. The infinite many solutions, I'm going to have the same number on both sides. Negative 12 equals negative 12. Now the no solution, I'm going to have different numbers on both sides, like 3 and 4, right? Different numbers. And then if it is just one solution, those were the examples that I just did. So good luck on your homework.